Well, welcome to the December meeting of OzBerry, and I've got three projects to demonstrate: reSpeaker, GrovePi, and wireless sensor networks using XBee. Okay, looking at wireless networks first, what I had to do was to have a look at XBee, and we've already had an XBee based system in our home as part of our home automation system for the last 6 years. This was developed by my son Stephen, and it's been very successful. Easy to set up, and it works quite effective as in a mesh network. So in a large house we're able to cover the whole area using a network of XBees, the S2 model. What I had to do was to consider extending this with additional sensors, and to have a look at whether alternative communication modules based on Bluetooth and Wi-Fi could be interchangeable with the older S2 XBee modules. So this is a layout of a typical XBee module. So this could cost anything from $40 to $80, depending on the options, and quite often they have built-in I/O and their own microprocessor. One of the good things about XBee is that for wireless communications you can optimize it by selecting an antenna to maximize the power output. Also makes a good prototyping system, but you need to have a carrier to put it on proto boards, because the pin spacing is different from that of a proto board. So you have various configurations available for wireless networks. So not only is there the typical star arrangement as you have in Wi-Fi, but you can also have mesh networks, and this improves the reliability of communicating. One of the applications of XBee is to develop typical products like this. So I have one of these, and it allows input sensing and a number of relays to function very quickly in a home automation system. So on my project I was looking at a number of XBee modules. Here we've got the USB-B, and it's on a Cedino Stork version 3, where I'm looking at bridging between a XBee GPS module and going to a PC via a XBee USB module. The GrovePi is an interesting project in that it combines at the high end a Raspberry Pi, and at the low end an Arduino microcomputer, which is connected to Grove sensors and actuators. What I had to do was to test the GrovePi Python libraries, and I eventually did this with 56 Grove modules. So here are some of the Grove output modules, and you can see that there's an electromagnet, LED strips, motor drive for a robot, and various other displays based on LED, and quite a number of relay output options. Here are some of the LEDs, electromagnet, and the LED, and a liquid crystal display. The motor drive for the robot. and a couple of options on relays. For inputs, this slide shows the magnetic switch, the joystick, and other human interface modules, and a number of robot sensors, an analog to digital converter based on 12-bit conversion, and other sensors such as alcohol, a infrared person detector, vibration sensors, and sensors for water, current, and so on. A closer look at some of the sensors. The Grove communications module, here are some of them. The I2C hub allows you to extend the this connection from the Pi to the Grove sensors. And there's quite a number of options here. The Grove environmental modules include humidity and temperature, sun, and the sun sensing splits the electromagnetic light spectrum into infrared, visible, and ultraviolet. It calculates directly the ultraviolet index, and all of this is done on a I2C Grove module. This is a good introduction to computing and hardware, and it shows you how you can use modules, logic modules like AND, OR, and NOT to drive motors, LED strings, based on simple logic. A couple of one of the most interesting sensors is the Grove color sensor. And another module is the real-time control. So if you're away from the internet and you need to find out the time, this will give it to you without being connected to the internet. Another LED, which is a programmable color LED output unit. So other Grove modules, these are mounted on Lego mounts or wrappers, and they can plug into a Lego baseboard. Here a line follower is being tested, and the line would be typically used as a tracking device for a robot. So we're testing whether the Grove line follower is able to detect the line. Grove can also be used in the garden, and here's a moisture sensor which can be used to see whether your plants have enough water. Another output module similar to a relay, but the MOSFET has a much faster response time and can be used repetitively without bouncing as a relay does. Another water module, and here's an interesting module based on near-field communications, which allows the Grove to sense cards like the Opal card and use these in various applications. Here's Jason testing the Grove LED strip. The Grove I2C motor module, and an interesting one is the Grove alcohol module, testing the strength of Chinese whiskey. Okay, a project that I demonstrated at the Sydney Mini Maker Faire was voice in the car, and it was a project that was part of a competition from the Chinese company Seed, and this was my proposal on how I would use a speech recognition system to control the layout of a dashboard. So I got involved not only in the initial conception of this product, but I was also an alpha tester, and this was quite interesting because I had to find out whether the system was working according to specs, but also consider how a hobbyist might use it. And the project I worked on was based on MQTT, where the Rio Speaker would be a client to a home automation system that had a MQTT server, and the Rio Speaker could then control any device on the home automation network. Okay, so this is another slide of where I won on the competition for the voice system. My son Jason having a look at Rio Speaker. And Rio Speaker can be an interesting device and has great potential for people with disabilities. So people who have a problem with speech or who have sight problems can control switches in their house by just talking to them. So the arrangement that I had was to test 2 alpha devices, and these are the ones that I use for testing. The second, Alpha 2, had an interesting input-output controlled by an Arduino computer, where the color LED lights could be synchronized to music. Here is the system architecture for Rio Speaker, and here you can see how it's going to be used. So 2 major applications. One is for voice recognition for controlling your surroundings, and the second one is for music streaming. So Rio Speaker is based on a core, and it uses the microprocessor, the MT7688, with an operating system, OpenWRT, which originated with routers, particularly on home Wi-Fi systems. So you can see the board layout, the circular layout of the Rio Speaker core. This is the one I had, and here you can see it has a microphone on the right together with a Wi-Fi module. The output allows it to be connected to an audio system, so you can hear, and you can also have this audio jack as a speech input. The rear shows you a little bit more about those connections, including a SD card for extending the operating system. You notice that it has quite an advanced codec chip, and this is used for processing the speech. 3 extensions are available for Rio Speaker to make it more like a Amazon Echo. The microphone array adds 7 extra microphones with an additional codec. The codec on the core is switched off, and this allows you to use reSpeaker in a noisy environment, and also to do things like beam forming and localize the speaker. Another extension is to use the Grove input-output. That is, use Grove modules for extending the Rio Speaker system. There's also a Meow King audio system available if you want to pay a bit more money, and if you get that module, it becoming very much like a Amazon Echo speech recognition system. A little bit more on the microphone array. It's on another circular board which sits on top of the core module, and it can do things like far field voice capture, acoustic source localization, beamforming, noise suppression, reduce reverberation, and echo cancelling. So the microphone array also has 12 RGB LEDs and an advanced codec chip. The Grove module, and it allows you to add either digital, analog, or I2C Grove modules. Now, I explored the Rio system, and some of the software modules I was looking at include the simple Linux record and sound utilities, and most of my time was spent on the Python and how it would connect to the Microsoft Bing. So a little bit more on the online processing for speech to text recognition with Python, and how you would set up the system with Microsoft Cognitive Services. I had to learn a completely new operating system, and you set up the reSpeaker as an attachment to the home Wi-Fi network. So you put it into station mode. It comes pre-configured in the AP mode, Wi-Fi AP mode. Another challenge was to learn a Linux-like system, but it's nowhere near like the Raspberry Pi Debian. You have to be careful. It has quite limited resources, and it has different utilities. While I was playing around with the advanced admin services, I managed eventually to corrupt some of the settings, and this is a little bit of a hazard for newbies that are not that familiar with the OpenWRT operating system. Some of the web services that I explored were to connect the Flask framework using Python to reSpeaker. I found this to be quite difficult, and even though that it was achieved, there was a problem with synchronization. Here's a little bit of the code that I was involved in. I got some help from my son Stephen with this. Well, my goal was, could I get it working on Node-RED? And using a RESTful web services and WebSockets, I was able to achieve some results in this area. I found that using a phonetic alphabet, I was able to get up to about 96% word recognition accuracy, and this was the only numerical tests which I did. So these individual word tests are quite different from continuous speech, and you could spend a lot of time just on this area of testing. So the 2 months that I spent as an alpha tester were quite interesting with good results. So I was one of 10 alpha testers. The others were scattered around the world, and we had our own group on Google+. The interesting thing was 2 months later, the group didn't respond to requests and were no longer involved in testing the product. So I managed to corrupt the operating system and could no longer operate reSpeaker. So this is quite interesting because it will depend on good support from seed if this product is going to be a success. So I'm now currently testing the support you get online from seed. Well, here's my wish list. The first one I've already achieved, that is connecting Rio Speaker as a MQTT client, and this works quite successfully. It's going to be very critical to have APIs for various languages, and I'm still waiting for seed to provide these. Plenty of promises, but it'll be interesting to see whether these are delivered. I was involved in the Kickstarter campaign, and I bought two products here. Well, I bought one and my wife bought the other, and it'll be a wait until November before we get our first delivery. The Kickstarter campaign had a target of 40,000, and the result eventually was 196,000. So it's quite a successful campaign. And here are some of the references I used throughout this project. So thank you for listening.